Hi student, in this video we'll be discussing our chapter known as haloalkanes and haloarenes, so of class 12 CBSE. So what are haloalkanes and haloarenes? So halogen, here it is basically the group 17, that is fluorine, chlorine, bromine, iodine. So if these halogens have been replacing one of the hydrogen atom of alkanes, then they form haloalkanes. So you can see this as a methane group. So methane is nothing but CH4. One of the hydrogen atom has been replaced by X. X is nothing but halogen. Then they form as haloalkanes. So replacement of hydrogen atom in an aliphatic hydrocarbon. So what is aliphatic? It is either open chain or straight branch chain. So either a straight chain or branch chain hydrocarbons. So anyways, alkanes means carbon-carbon single bond only. So any one of the hydrogen atom has been replaced by halogen, then they form a haloalkanes or alkyl halides, RX, alkyl halides. Is that clear? So then they are called as haloalkanes. Now what are haloarenes? Arenes in the sense nothing but benzene ring. So you can see this benzene ring. So benzene ring, anyways, we know there is this hydrogen atom attached to the carbon atom. So any one of the hydrogen atom is being replaced by halogen, then they form an haloarenes. Is that clear? Replacement of hydrogen atom in an aromatic. Aromatic is nothing but benzene ring. Benzene rings are aromatic, alternate single and double bond, and they are on plane. So they are called as aromatic group. So one of the hydrogen atom has been replaced by an halogen. Then they form an aryl halides or haloarenes. Aryl is nothing but a benzene ring, or they are also known as haloarenes. Now let's go with the classification of haloalkanes and haloarenes based on the number of hydrogen atom replaced by halogen. So you can see this mono haloalkanes, dihaloalkanes, trihaloalkanes. So mono, di, tri in the sense it's just 1, 2, 3. So here you can see that one hydrogen atom has been replaced by halogen, then it is mono haloalkanes. So initially methane CH4. So one hydrogen replaced by halogen, it becomes CH3X. Okay, so methyl chloride, methyl bromide, so they are like basically like that. Okay, so now dihaloalkanes, so two halogen attached, so trihaloalkanes, three halogen attached. So same thing we can also go with arenes, monohaloarenes, dihaloarenes, trihaloarenes. One of the hydrogen atom replaced, two hydrogen atom replaced, three hydrogen atom replaced. So you can see these examples. So they are based on the number of hydrogen atom replaced here. So next we will go with the next set of classification. So here if you see, we can classify haloalkanes as primary, secondary, tertiary haloalkanes. So now here if you see the halogen, that is fluorine, chlorine, bromine, iodine. So it has been attached to a carbon atom which is having an hybridization of sp3. sp3 in the sense we know it is like four bonds, it is having four single bonds. Okay, then you can go with sp3. So halogen, when it is attached to an sp3 carbon atom but it is having one R alkyl group and two hydrogen, then it is primary. If suppose there is two alkyl group and one hydrogen, it is secondary. Okay, and if there is three alkyl group, there is no replaceable hydrogen atom. All the hydrogen atom has been replaced by R group, alkyl group. Then it's called as tertiary haloalkanes. Primary, secondary, tertiary haloalkanes. Is that clear? So now here it is only one R group, and here two R group, and here three R group. Then it is primary, secondary, tertiary. So now we can also classify haloalkanes further as allylic, benzylic, vinylic and aryl halides. Okay, so now let's see how they have been classified. Allylic halides are basically the halogen which is attached to a carbon atom, which is an sp3 carbon atom, in turn attached to a carbon-carbon double bond, which is sp2. Okay, so first the halogen will be attached to a carbon atom which is sp3, and the second neighboring carbon atom will be sp2 carbon atom. So then they are known as allylic halides. So even in this example you can see the halogen is attached to the carbon atom which is having sp3 hybridization. So the second carbon atom is a carbon-carbon double bond which is having an sp2. So it is an sp2 hybridization. So the first halogen will be attached to an sp3 and the second carbon atom, the neighboring carbon atom, will be an sp2. Then it is known as allylic. Now benzylic. Benzylic itself is, the word itself is clear. Benzylic means benzene ring. So now here if you see, the halogen is being attached to an sp3 carbon atom that in turn attached to an sp2 carbon atom. In turn in the sense, now you know there's a benzene ring. It has alternate single and double bond. So then it will have sp2, right? So first halogen will be attached to sp3. Then second carbon atom is sp. first attached to sp3, second is sp2. So here also halogen, here this example you see halogen is in the last, attached to an sp3, second carbon is sp2. Okay, so in the first two example, that is allylic and benzylic, first carbon halogen has been attached to an sp3 hybridization, directly attached to an sp3 hybridization carbon atom, second carbon is sp2, because second next two classification will be different. So here the halogen is directly attached to an sp2 hybrid carbon atom. Okay, that is nothing but vinylic and aryl halides. So let's see what is vinylic. Vinylic is basically when halogen is attached to carbon carbon double bond, wherever carbon carbon double bond is there, right? So that carbon directly halogen will be attached and it is called as vinylic. So here see halogen directly attached to carbon carbon double bond. So this is also an example of vinylic. Now you see next example is aryl halides. So aryl in the sense nothing but benzene. Okay, so here directly the halogen is attached to a benzene ring, either normal benzene ring or substitute benzene ring, a methyl benzene. Okay, so anyways it can be any substituent, it can be in that case. So when halogen is attached to directly to a benzene ring, then it is called aryl halide. So if you remember, there's also something called benzyl. So there is also benzene involved, but it is first attached to an sp3 carbon atom, and the second one, so second carbon, neighboring carbon was sp2, which was a benzene carbon atom. But in case of aryl, it is a direct linkage. So direct halogen get attached to the aryl halides. Okay, so the first two classification was the halogen attached to sp3 hybridization, and second was sp2, second carbon was sp2, and the second two example, that is last two example, vinylic and aryl halide, the halogen was directly attached to an sp2 carbon atom. Okay, so that is also very important, very as per the exam point of view. Okay, so this is all about classification of haloalkanes and haloarenes. Hope you understood. Thank you so much.